What is alkalimetry?
Alkalimetry. It's a type of volumetric chemical analysis. Inaalaw niya tayo na ma-determine yung level ng acid solution using an alkaline solution of knowing concentration and a sufficient indicator. Example niya yung boric acid. Measured siya by using alkalimetry method. When it dissolved in a mixture of water and glycerol, it behaves like a strong monobasic acid, and then it can be titrated when a standard solution of alkali using phenolphthalein as an indicator.
What is boric acid?
Boric acid is a water-soluble white compound that occurs naturally. It consists of hydrogen, oxygen, and boron. At ayon sa mga pag-aaral, ang boric acid ay mayroong antifungal and antimicrobial properties. Researchers also found out that it works to treat Candida albicans and the more resistant strain, Candida glabrata. It is available over the counter in gelatin capsules that is inserted to the vagina. In homeopathic medicines, it is used for vaginal discharge and itching. The diluted solution is also used for diaper rash, insect bites, and stings. But always remember that boric acid can be irritating to the skin and may cause severe reactions.
Materials.
The assay of boric acid is based upon the alkalimetry method. Being a weak acid, it cannot be directly titrated accurately with strong alkali. But when it is dissolved with a mixture of water and glycerol, it behaves like a strong monobasic acid, and it can be titrated with a standard solution of alkali using phenolphthalein as an indicator.
Reagents.
I will be discussing about the reagents of boric acid. In boric acid reagents, first that you need is 2 grams of boric acid. Additionally, boric acid is low in toxins if eaten or if it contacts skin. However, in form of borax, pwede siyang maging corrosive to the eye. Borax can also be irritating to the skin. People who have eaten boric acid have experienced vomiting, stomach aches, and diarrhea. Next naman po ay 100 ml of glycerin and water yung kailangan mo. Equal volume dapat ang glycerin at water. In terms of glycerin, it is also known as glycerol, which might be from vegetable oils or animal fats. Its molecular formula is C3H8O3. Lastly po, we have the 1N sodium hydroxide, which is sodium hydroxide is used to produce soaps, rayon, paper, products that explode, and petroleum products. And that's our discussion about the reagents of boric acid.
Laboratory instruments.
So the lab instrument or apparatus that we are needed for the alkalimetry of the boric acid. So first is no other than the Boric. Second is the pipette. Third is the conical flask, the Erlenmeyer flask. Fourth is the metric flask. Lastly is the measuring cylinder. So those are the things that are needed for preparing for alkalimetry of the boric acid.
Special precautions.
Boric acid is a particularly hazardous substance, so laboratory goggles, coats, and gloves must be worn before and while working with boric acid. So in case of direct contact or exposure with boric acid, you should wash your skin with plenty of water and soap, and you can also remove your clothing immediately. So in case of inhalation, you can move to fresh air and seek medical attention if irritation, discomfort, or vomiting persist. So in handling boric acid and in storage, you should keep the container tightly closed when not in use, and it should be stored in a cool, dry, well-ventilated
Procedures.
Procedure for the assay of boric acid. Titrate with 1N sodium hydroxide after dissolving about 2 grams of accurately weighed boric acid in 100 ml of mixture of equal volumes of glycerin and water, previously neutralized to phenolphthalein TS. Then remove the pink color by adding 50 ml of glycerin that has been neutralized with phenolphthalein TS and continuing the titration until the pink color reappears. Each 1 milliliter of 1N sodium hydroxide contains 61.83 mg of boric acid or H3BO3. Because the metaborate ion is strongly basic, the forces above with the reaction to the left, boric acid behaves a very weak monobasic acid. Long before an equivalent amount of sodium hydroxide is added, the BO2 ion concentration is high enough, and the H ion concentration is consequently low enough to cause a change in the color of the phenolphthalein indicator. When glycerin is added, it forms a slightly dissociated complex with the metaboric ion, preventing the reaction from reversing. So, as a result, the pH remains below 8.0 throughout the titration until an equivalent of sodium hydroxide is added. In other words, when glycerin is present, boric acid behaves like a sufficiently strong monobasic that titration with standard alkali is possible when phenolphthalein is used as an indicator. In this titration, H3BO3 or boric acid behaves as a monobasic acid. 1 mole of is equivalent to 1 equiv, and the equivalent weight is 61.83 grams. Each milliliter of 1N sodium hydroxide contains 61.83 mg of 1 MEq of boric